Good afternoon, class. We are looking at exam 3 review, chapter 3, differentiation rules, chapter 4, application of differentiation, and we are looking at part 2, covering section 3.10, linear approximation and differentials. So, what happens in this section, 3.8, differential and linear approximation? Here's the definition. You have a function y equals f of x. We define dx called the differential of x by dx equals delta x. And in other words, as you go from one point to the next on the curve, the distance along the x-axis, there we call it the run. This is delta x or dx, or this distance bp, or this distance dc. They are all the same. Dx or delta x. And the y called the differential of y by dy equals f prime of x dx. This is the precise definition of dy, which is simply take the derivative multiplied by dx. If you look at f prime of x with which is dy dx, and treat it as a fraction, the cross product results in dy being f prime of x times dx. Graphically, delta y is f of x plus delta x minus f of x. In other words, as we go from point P to point Q, if you draw a line, the rise along the curve, this distance, is delta y, which is equal to this distance BQ, and BQ is CQ minus BC, which is the same as PD. In other words, f of x plus delta x minus f of x. That's it, f of x plus delta x minus f of x. So what is delta y? Rise along the curve. What is dy? Is rise along the tangent line. If at point P you draw a tangent line, dx or delta x are the same, but dy, which is rise along the line, the tangent line, is this distance AB. And as you can see clearly, this distance AB is not equal to this distance delta y. AB is not equal to BQ. However, we can replace delta y by dy for a function f which is continuous and differentiable function with a small delta x if delta y is difficult to evaluate. Sometimes it's very difficult to evaluate delta y, and so we evaluate dy and we approximate it by that. Bear in mind, this has been blown up, so for the sake of observation, normally delta x is extremely small, and then dy and delta y become very close. So we write f prime of x is dy dx. It is approximated by delta y over delta x. Remember, this is the average rate of y with respect to x. This is the instantaneous rate of y, rate of change of y with respect to x. And therefore, delta y becomes f prime of x times delta x, roughly. So, to recap this, delta y is precisely f of x plus delta x minus f of x. And in this equation, if I want to solve for this, I'm going to use minus f of x and move it to the left, becomes plus. Therefore, f of x plus delta x is f of x plus delta y precisely, on the one hand. On the other hand, we said when f prime is dy dx, that means dy is f prime of x dx. And instead of delta y, we can approximate it with dy. So this formula, f of x plus delta x, is approximated by f of x plus dy. If you look at this point and you draw a tangent line and you use the point slope, y minus y1 equals m times x minus x of 1. Move the y1 to the right and replace the m with f prime of a, x of 1 with a, y sub 1 with f of a, and change the y to the name L of x. So L of x is f prime of a times x minus a plus f of a. Do I have to memorize it? Absolutely not. This is the tangent line. So if you hear linearization, it simply means find the tangent line. Let's look at some examples. First, we want to differentiate, reminding everyone how we differentiate. Y equals natural log of sine x. And as you recall, when you have a natural log of g of x, you flip it over times the derivative. So flip this over, you get 1 over sine x times the derivative of sine x, g prime of x. The derivative of sine is cosine. And these are all x, everybody. So cosine over sine, as you remember, is cotangent. Ultimately, all of these variables must be the same. X or theta makes no difference as long as they're all the same. What about this function, y equals e to the power of x over 1 plus x? You may recall that we've done this. We are going to differentiate by using f over g, the quotient rule. And as I mentioned, I would write the quotient rule from the memory, and I will follow that. F prime g minus g prime f over g squared. So f prime is itself e to the power of x times g, which is 1 plus x, minus the derivative of the denominator g is simply 1, so minus 1 times the numerator e to the power of x, and just write the denominator in the parentheses, then square it, that's g squared. Now, you have to simplify the numerator, you distribute, you get e to the power of x plus e to the power of x times x minus e to the power of x. These two cancel each other, and we put the x in front. We get x e to the power of x over 1 plus x quantity squared. I hope you remember this. We had done this. So why am I coming up with this question? The same question has been done, is that I want to find the differential of each function. So f prime of x is dy dx, dy is f prime of x dx. So because we want dy for this one, simply the same thing, times dx. If we go with, maybe it's easier to go with theta. Let me just erase everything and change everything to theta. Okay. So you get dy equals whatever you had here times d theta. What about part B? The same thing. Because the variable is x times dx. So dy is the same thing times dx, everybody. So we want to pay attention to the variable. In this case, we use theta, and so d theta. And use the in this case, the independent variable was x, so we use dx. For y equals x times 4 minus x quantity cubed, find dy, and then find dy and delta y with the given numbers. So first and foremost, the moment you see dy, just find f prime of x. So f prime of x is dy dx. And x has the derivative of 1. So let me just write fg. And we are going to use the product rule, which gives you f prime g plus g prime f. So f is x, the derivative is 1 times g, which is 4 minus x quantity cubed, plus g prime. So what is the derivative of this guy? 3 times 4 minus x squared times the derivative of the inside, negative 1 times f, which is x. In other words, this is f prime g. This is plus g prime f. And all you have to do is simplify by taking a common, excuse me, common denominator. So dy dx, or f prime of x, becomes what's in common between the two, which is 4 minus x squared times this one. If you divide, gives you 4 minus x. And this one, if you divide, gives you positive 3 minus 1 on x, which is minus 3x. So this one, we combine these two into minus 4x. And now we take the negative 4 out. So this part is negative 4 times x minus 1. And we rewrite dy dx as negative 4 times x minus 1 times 4 minus x quantity squared. Again, notice the only calculus step was the first step. And so that's dy dx. What is dy? The same thing times dx. So dy is exactly the same thing times dx. Minus 4 times x minus 1 times 4 minus x quantity squared times dx. Now we are going to plug in and replace the x with 5, dx or delta x with 0.1. So we get minus 4 times 5 minus 1, 4 minus 5 quantity squared times 0.1. And this is easy to calculate. This is 4. This is negative 1. When you square it, you get positive 1. So you get minus 4 times 1, which is negative 16, times 0.1 is negative 1.6. In fact, we'll see why a lot of times dy replaces delta x by an approximation. Because if I want to use delta y is f of x plus delta x minus f of x, which means f of 5.1 minus f of 5. So f of 5.1 minus f of 5. So I have to go back to the original function, replace 5.1. So I get 5.14 minus 5.1 cubed, minus then I replace it with 5. So 5.1 times 4 minus 5.1 quantity cubed minus 5 times 4 minus 5 cubed. So this is not a big deal. It's negative 1 cubed. It remains at negative 1 times negative 5 becomes positive 5. This one is not too bad, but anyways, it's a tad easier to do it with the calculator. You do that and you get negative 6.7881 minus 5 or plus 5, negative 1.7881. Notice this we basically did it without the calculator. This one you could do it without the calculator. It takes a tad longer, but as you can see, the two numbers are close. And the smaller the value of delta x or dx in a matter of comparison to the choice of x, the closer these two values are. So I hope it's clear, everybody. Use differential to approximate 51 squared. So what do we need? First, we need a function that we are going to work on. So what is the function? How do we come up with the function? We read the question. The question says approximate 51 squared. The operation is the function you need, the operation of squaring the number. So f of x must be x squared. So the operation is squaring the number. The next one is choose a number x close to 51 for which squaring is easy to compute. Everybody knows the closest number to it is 50 if you want to square it. 5 squared is 25, 0. Because you're squaring it, you're going to use two of them. If you're cubing it, let's say it was cubed, 5 cubed, and then you need 3 zeros. This is how we did that. So that would be the best choice, the closest choice. And so the next is to go through the process. And at this point, f of x plus delta x will be approximated by f of x plus dy. And what is dx, the difference between the two numbers, which is positive 1. I want to make sure we understand what happens here. We have the information about 50. We may not have it about 51. I'll quickly go over that. This has been explained in algebra in a different manner. I'll show you. But anyways, so we go from 50 to 51, which is larger. And so dx is positive 1. On the other hand, if you wanted 48 squared, just as an example, the question was asking what is 48 squared. We would use exactly the same thing, but dx would be negative 2, which is 48 minus 50. So, and what it means, positive dx means the result must be larger than this number. Negative means must be less than that. What I want to remind you, and I'm going to erase it in a moment, but quickly I'll go over that. Remember, a plus b squared is a squared plus 2ab plus b squared. So probably when you were studying that, one of the examples they gave you was this. So you can easily do this in your head. 50 squared is 2500. 2 times 50 times 1 is 100 plus 1 squared, and you get 2601. So you could do that in your head pretty fast. But the idea here, of course, is to use the differentials. This probably was explained to you in algebra when the identity a plus b quantity squared was being discussed. In any event, I'm going to erase this and continue with this using differentials. So f of x plus delta x is f of x plus dy, and we have f of x, but what about dy? First, we have to differentiate. F prime of x, or dy dx, is 2x, which makes dy 2x dx. And now we replace the f of x, we replace the dy, we get x squared plus 2x dx, where f of x comes from the f of x equals x squared, and dy comes from dy 2x dx. And now all you have to do, find 51 squared, or f of 51, or f of 50 plus 1, which means this is x, this is delta x, everybody. X, delta x. So plug it. You get 50 squared plus 2 times 50 times 1. Obviously, 2 times 50 times 1 is 100. 50 squared is 2500. They add up to 2600, which is obviously very close to the actual value of 2601. And again, the reason it's close, because delta x is extremely small compared to the choice of x. The other methodology, which will give you the exact answer that you found here, not this one, but this one. Differential or linearization will give you the same result. Remember, linearization simply means find the tangent line. So you want L of x for which function? For this function. At what point? At x equals 50. So tangent line L of x is what we are looking for f of x equals x squared at x equals 50. Now, what is the pair? Of course, you have to put the f of x, you have to put 15 f of x, which you already know the answer is 2500. So you have the pair 50 and 2500. But what is the slope? You also need the slope. You go back to this one and replace the 50 into f prime of x. 2 times 50 makes it 100. So how do you find L of x? You need a pair 50 comma 2500. So this, you put it back into the original function. This you put it back into original function and it gives you the pair. And this one, you put it back into this one to get this slope. Y minus y1, we're going to use the easy way out. That means y minus 2500 equals m100 times x minus x of 1, x minus 50 is 100x. This is minus 5000. Move this one and it simplifies to 100x minus 2500. You want 51 squared, you want L of 51. So if you plug in x equals 51 and you evaluate it, you get exactly the same answer as expected. So that's using the differential, everybody. Here's another example. We want to use differential to approximate the square root of 27. So again, number one, we need a function. What function are we using? We look at this and we say square root of 27. That means the operation of square rooting a number, square root of x. The second step is to choose a number x close to 27 for which the square root is easy to compute. The closest number to 27, where we can take the root easily, is number 25 because square root of 25 is 5. So that would be the best choice, closest number. So from 25 to 27, there's a difference of 2. That is delta x over dx. Again, just for the sake of argument, just to make sure we understand that if the question was, okay, find square root of 24, then dx would be negative 1 because 25 is what we have at hand easily. From 25 to 24, it must get smaller. The dx must be negative. So negative 1 versus positive 2. So if that is the case, then f of x plus delta x is f of x plus dy, and we have f of x, we don't have dy. We are going to find that, which means to differentiate this, we're going to change this to x to the power of 1/2. And now f prime is 1/2. X to the power of 1/2 minus 1, negative 1/2, which means 1 over 2 x to the power of positive 1/2, or 1 over 2 square root of x. What is dy? The same thing times dx. And so we are replacing the f of x. We are replacing dy. And now we can calculate square root of 27 by evaluating f of 27, which is f of 25 plus 2. So x is 25, delta x is 2, everybody. So into this, replace the x with 25, same here, and dx with 2. Of course, 25 is 5, square root. This is 5. These two cancel each other. 5 plus 1/5, 5 and 1/5, or 5.2. Now, if you put it into a calculator, everybody, this is pretty close. If you stop at this one, you have to change it to 2. If you stop at this one, the second one also, because of 6, you have to take it up and it becomes 5.20. You have to put the 0 to represent the exact amount. So that's how close it is. And again, because the choice of x makes it reasonable, because the x or delta x is pretty small in a matter of comparison. Again, I want to show you how the linearization works by using y minus y1 equals m times x minus x of 1. So linearization, that means we are looking for the tangent line, which we're going to call L of x, for the function f of x, which is square root of x, at x equals 25. So y minus y1 equals m times x minus x of 1. So what is the pair? Obviously, you plug in 25 and you get 5. So this is the pair class. Plug in 25 and you get 25, comma 5. So that's the pair. What is the slope? You go back to f prime of x. So you put it in here. You get 1 over 2 squared of 25. Remember, this becomes 5. 2 times 5 is 10. So 1 over 10. So L of x, the pair is 25, 5. F prime of 25, m is 1 over 10. So y minus 5 equals 1 over 10 x minus 25. And I'm going to leave it for you to simplify this into y or L of x equals 1 over 10x plus 5 halves. If you replace the x with 27, becomes L of 27, and it becomes exactly what we have here with the fractional format or decimal format. Linearization will result in the same answer. It must and it will. We are going to move on. Use differentials to approximate cube root of 63.5. Well, so what do we do? Number one, we need a function. How do we come up with the function? Just read the question. Cube root of something, 63.5. So f of x must be cube root of x. The next thing is to choose an x to be a number close to 63.5 for which the cube root is easy to compute. Clearly, the closest number to this must be 64, because cube root of 64, we should know it's 4. dx is the difference between the two, which makes it negative 0.5. So 63.5 minus 64 is negative 0.5. What it means is we know cube root of 64 is 4. We don't know what's cube root of 63.5 because dx is negative, for sure has to be less than that. And it will work out to be less than that. And that's the idea, everybody. So f of x plus delta x is f of x plus dy. We do have f of x. We don't have dy. We need to work on it. So we work on that. We change this to x to the power of 1/3, so we can differentiate it as 1/3 x to the power of 1/3 minus 1 or negative 2/3. We rewrite this by taking this down, making it to the power of positive 2/3, or cube root of x to the power of 2. So f prime of x is 1/3 times cube root of x to the second power. So what is dy? The same thing, times dx. So if you want to multiply this one by dx, you can just say 1 times dx, or simply put the numerator as dx. We replace f of x, we replace dy, and now we are in business. Cube root, okay, that's where they come from. Cube root of 63.5, that means f of 63.5, which means f of 64 plus the x or delta x, which is negative 0.5, which means into this, anywhere you see x, replace 64. dx, replace with negative 0.5. That's the meaning of it. Let's do that. Of course, this is 4. This is 4. So this is 4. This is 4 square root 16 times 3 is 48. And I'm going to put this one as negative here. And instead of 0.5, I'm going to use 1/2. Why do I do that? Because I want to come up with an exact answer for this process. And as you can see, this is a complex fraction. So it's 1/2 times 48, or 1/96. So 4 minus 1/96, which is 3, and 95/96. I want you to pay attention to this part. And then, of course, I use the decimal, and I'll tell you why in a moment. But this is exactly when we go through the process. The reason I put it in this format, if you put this into a calculator, it gives you this number. And notice the first 4 decimals are identical. In fact, if you want to stop here, you have to change it to 6 because the next number is 5. The same thing here, the next number is 8. You have to change it. So it's pretty precise because the choice of dx compared to x is extremely small. Now, linearization means finding the tangent line for the function f of x equals cube root of x at x equals 64. So what is the pair? You know, when x is 64, cube root of that is 4. So that is the pair, believe it or not, 64, 4. But what is the slope? You go back to f prime, you go to this one, is easier to calculate. So if I replace the 64 here, I get 4. Square it 16 times 3 is 48. 1 over 48, okay, is the slope, everybody. So f prime of 64 is the slope. And so we are going to use y minus y1, that means y minus 4, equals m 1 over 48 times x minus x of 1, that means x minus 64. And if you distribute and simplify, you find y or L of x to be 1 over 48 times x plus 8 there is. Now, if you plug in 63.5, everybody, L of 63.5 into this, you get 63.5 over 48. And the methodology is, because this is a decimal, it's easy. If you multiply it by 2, becomes 127. You multiply this one by 2, becomes 96. And you add up two fractions, becomes exactly what the number you see here, 3 and 95 over 96. And that's important to understand. So a quick recap, you find the function, just read the operation, you find the closest number, basic math, and then use the approximation f of x plus dy. If they ask you for the linearization, they're asking you to come up with a tangent line. But both will give you the same answer. Just follow the question the way they ask you. The radius of a blood vessel is 1.4 millimeters. A drug causes the radius to change to 1.3 millimeters. Use differential to find the approximate change in the area of a cross-section of the vessel. So the cross-section is in the form of a circle. It has some radius to begin with. In this case, more specifically, R is 1.4 millimeters. A drug causes it to change to 1.3. It's going to get smaller. Now we have a new radius, R, and the new radius is 1.3, and this part is dr or delta r, the change in radius. So the difference between the two is the dr. So we should know, because we are discussing the area is pi r squared. Originally, the radius is 1.4. The new one is 1.3. The difference is dr or delta r is 1.3 minus 1.4 is negative 0.1, same units, millimeters. Okay, negative means it's shrinking, the area is getting smaller. And so what we are looking for is the approximate area of this shaded region. So that's understanding the problem. So having said that, we know that f prime of x is dy dx. By the same token, a prime of r must be dA dr. So going back to this one, dy is f prime of x dx, everybody. dA is a prime of r dr. First, I wanted to show you how we arrive at it. And since a is pi r squared, dA dr would be pi, doesn't change because it's a number. Now, r squared, the derivative of r squared with respect to r is simply 2r times 2r or 2 pi r. So that's dA dr. What is dA? 2 pi r dr. So dA is 2 pi r dr, Replace the r with 1.4, dr with negative 0.1. 1.4 times 2 is 2.8 times negative 0.1 is negative 0.28 pi millimeters squared, the units of area. And again, going to keep it with pi. If you go with an approximation, you get this number. What does it mean? The area of the cross section of the vessel is decreasing by this much. When you say decreasing, you don't write the negative sign anymore, okay? 0.28 pi. Can we find the exact area? The exact area is delta A, change in the area, which means calculate the area for the smaller one, pi r squared, pi times 1.3 squared. Calculate the area for the bigger one, pi r squared, pi times 1.4 squared, and their difference. So I have factored out the pi times 1.3 squared minus 1.4 squared, and that's exactly negative 0.27 pi millimeters squared, which is very close. So this is an exact answer. This is an approximation, and they are very close. A bacterial colony has a population of P of t equals 20t over 10 plus t squared in millions t hours after a nutrient is introduced. Use differentials to approximate the change from t equals 2 to t equals 2.4. So what's happening? T is equal to 2, and their difference, 2.4 minus 2 is 0.4, or dt or delta t, and we want the approximate change. That means we want dp. So t is 2. dt is the difference between the two, positive 0.4, because we go from 2 to 2.4, and dp is what we are interested in. Which means, given p of t, you have to find p prime of t, which is dp dt. Given p of t, you have to find p prime of t, which is dp dt. And because dy is f prime of x dx, dp is p prime of t dt, and you're done. So first, we have to differentiate, which means we are going to go with the quotient rule. We are going to write f over g and use the quotient rule. F prime g minus g prime f over g squared. So p prime or dp dt is, let's use the quotient rule, everybody, which means f prime 20 times the denominator g, 10 plus t squared, minus g prime, the derivative of the bottom is simply 2t, times the top function f times 20t, over the bottom function squared, 10 plus t squared to the second power. We're going to distribute number 20, we get 200 plus 20t squared minus 40t squared. We can combine these two, and the final answer is 200 minus 20t squared over 10 plus t squared, 20t squared. So what is dp is exactly the same thing times dt. Replace the t with 2 and dt with 0.4. So we get 200 minus 20 times 2 squared over 10 plus 2 squared quantity squared. And this is for everybody. 10 plus 4 is 14. Squared is 196. 4 times 20 is 80. 200 minus 80 is 120. So we get 120 at top, 196 at the bottom, times 0.4. We get 0.245 millions, which means 245,000 bacteria. That's an approximation. What would be the exact? Delta P, change in the population, which means P of 2.4 minus P of 2. That's the meaning of it. Now, I'll let you do that. Just plug in 2.4, evaluate it. Plug in 2, evaluate it. It gives you 0.189. And that means 189,000 bacteria. Measurement error. In a manufacturing process, ball bearing must be made with a radius of 0.6 millimeters. With a maximum error of plus minus 0.015 millimeters, use differentials to estimate the maximum error in the volume. So here's the ball bearing, those in between. So the area, the volume is supposed to have the spherical shape is supposed to have a radius of 0.6. By the way, the volume is 4/3 pi r cubed. We should know that. The volume is 4/3 pi r cubed. So it's supposed to have a radius of 0.6. It may go up, it may go down by this much. If it's smaller, then the radius is 0.6 minus 0.015, which is 0.585 millimeters, and it's still okay. If it goes and gets smaller than that, then it's too loose and it may fall off. On the other hand, may be bigger by this much. So even if the radius is 0.615 millimeters is fine. If it's larger than that, then those get stuck. That's the idea. So the radius is supposed to be 0.6. Delta R or dr is 0. Plus minus 0.015 millimeters. And we should know the volume is 4/3 pi r cubed, but we are estimating the maximum error in the volume. That means dV. So given R is 0.6 millimeters, delta R or dr is plus minus 0.015 millimeters. The volume as a function of R is 4/3 pi r cubed. We want dV. Well, V prime of R is 4/3 pi r cubed, and we're going to find dV. So to do that, V prime of R or dV dr is 4/3 pi. That is not going to go away. It's just a number, everybody. This is a coefficient. Now you work with R cubed. You get, with respect to R, you get 3R squared. And of course, these two cancel each other. 4 pi r squared is the answer. What is dV? dv would be the same thing times dr. So dv is 4 pi r squared times dr. So replace the r with 0.6 and dr with plus minus 0.015. So we get 4 pi times 0.6 quantity squared times plus minus 0.015. Putting it into a calculator gives us plus minus 0.0216 pi. Keep it with pi. If you want to go with decimal representation, of course, the units of the volume, millimeters cube with the, so you can use that plus minus 0.0678584 cubic millimeters. Notice I use a lot of decimals because I really want to stick with that rather than that. That's what we do in calculus. Now, what would be the exact change? And the exact change for the upper portion and the lower portion are different because this is a nonlinear function. So you calculate the volume with the 0.6. That means 4/3 pi times 0.6 cubed. You calculate the volume with adding that. That means 0.615 quantity cube. Their difference is for on the upper part, and on the smaller side, you calculate the area with 0.585 also, and the difference. So here's the methodology for the exact answer, and there will be two different numbers, everybody. 4/3 pi times on the upper side, 0.615 cubed minus 0.6 cubed. But factor the 4/3 pi. I leave it for you to finish the job. On the other hand, for this one would be 0.585 cubed minus 0.6 cubed. This will be positive, this will be negative. And if you're mentioning it, if you're doing the writing, this means larger by that much, this means smaller by that much. And when you report it, in both cases, you report it with positive values. For y equals f of x equals sine x, find dy. So to find dy, we ignore it and we find f prime of x or dy dx first, which is obviously cosine x. So dy is the same thing times dx because dy is f prime of x dx, so cosine x dx. So that's very straightforward. Find its linearization at pi over 6. Linearization, I'm going to just use the point slope, so I need a pair and I need the slope. The slope is using f prime of x, so dy dx, so cosine of x or cosine of pi over 6, which we should know is square root of 3 over 2. And the pair is x comma sine x. That means pi over 6 and the sine of pi over 6, which we should know it's 1/2. So we have a pair. We have the slope y minus y1 equals m times x minus x of 1 means y minus 1/2 is m square root of 3/2 x minus pi over 6. So this, and you move the negative 1/2, make it positive 1/2. So this is square root of 3 over 2 times x. This 2 is minus square root of 3 pi over 12 plus 1/2, and this is precise answer. And you keep it as an exact answer. So y or L of x is square root of 3 over 2x minus square root of 3 times the pi is outside times pi over 12 plus 1/2. So that's the answer. the linearization or the equation of a tangent line, everybody? Approximate sine of 31 degrees. Bear in mind that pi over 6 means 30 degrees. And 31 degrees is close. So we are going to find sine of 31 degrees two ways. And bear in mind, sine of 31 degrees means sine of pi over 6 plus pi over 180, because pi radians is 180 degrees, everybody. We can use f of x plus dx is equal to f of x plus dy, the differential, where f of x is sine x and dy is cosine x dx. So what do? We replace the x with pi over 6 and dx with pi over 180. Now sine of pi over 6, we should know it's 1/2. Cosine is square root of 3/2, but nevertheless, we have to use a calculator. And pi over 180, that means 3.14159, and it continues indefinitely, divided by 180, multiplied by square root of 3 over 2, added to 1/2, you get 0.5151. I used only 4 decimals. Probably have to even use more, but that's one way to approximate it. The second way is to use the linearization. Sine of 31 degrees is sine of 31 pi over 180. And you are going to replace the x with 31 pi over 180. So use linearization. L of 31 pi over 180, which means square root of 3 over, that's why I kept it as exact. Square root of 3 over 2 times 31 pi over 180 minus square root of 3 pi over 12 plus 1/2. If you put this to a calculator, it gives you the same number as this. If you calculate sine of 31 degrees from a calculator, just put sine of 31 degrees, it gives you 0.515038. See, within 3 decimals they're identical. So it's very close. Okay. One side of a right triangle is known to be 20 centimeters long, and the opposite angle is measured as 30 degrees. with a possible error of plus minus 1 degrees. So that would be the error. That means either goes up, becomes 31 degrees, or maybe down 29 degrees. Use differentials to estimate the error in computing the length of the hypotenuse. What is the percentage error? Well, the first part is just using the differentials. And so what we do the drawing. You have to have the drawing. You have to have your variables defined. So this is the angle theta. One side is 20 centimeters opposite the angle that is supposed to be 30 degrees with a possible error of plus minus 1. So this is 30, theta equals 30 degrees. One leg is 20 centimeters. The opposite angle is 30 degrees. And this is d theta plus minus 1 degrees, or plus minus power 180. And we want to use differential to estimate the error in computing what? The hypotenuse. So therefore, we are interested in the change in that dx. So this is 30 degrees. One leg is 20 centimeters. The opposite angle, we're gonna call it theta, is 30 degrees. With a possible error of plus minus 1 degrees, that makes it d theta, which is more precisely plus minus power 180. In calculus, we always use radians, unless otherwise mentioned. And we want to estimate the error for the hypotenuse. That means the dx. So to do so, we are going to relate the two known values. We know that sine of theta is the opposite, which is 20, over the hypotenuse, which is x, in which case the cross product x times sine theta is 20, or x is 20 divided by sine theta, or 20 cosecant theta. So let me just actually write this. This means x is 20 divided by sine. And we should know, I write it here, cosecant theta is 1 over sine, or sine is 1 over cosecant, makes no difference. So x is 20 cosecant theta. Now we are ready to differentiate with respect to the independent variable theta. So we want dx d theta, which is 20 times. Now what is the derivative of cosecant theta? Is negative cosecant theta cotangent theta. So what is dx? The same thing, times d theta. So dx is the same thing times d theta. We are following that. Makes it negative 20 cosecant theta cotangent theta d theta. Let's plug in. So what is theta? It's supposed to be 30 degrees or pi over 6. What is d theta? Plus minus 1 degrees or plus minus pi over 180. So plug in. Minus 20 cosecant pi over 6. Cotangent pi over 6 plus minus pi over 180, and you put it into a calculator, you can come up with the answer. As far as the exact answer for this one is concerned, cosecant, remember, is 1 over sine. As you recall, sine of 30 degrees is 1/2. So you should know sine of 30 degrees or sine of power 6 is 1/2, which makes cosecant the reciprocal of that 2. Cotangent is square root of 3. So if we go with minus 20 times 2 times square root of 3 times plus minus pi over 180, we end up with this precise answer, plus minus 2 square root of 3 pi over 9. Putting it into a calculator, maybe with a couple of decimals, gives us plus minus 1.21. And this is the x, the change in x, units for x centimeters. You have to use the units for x, 20 centimeters. So the same unit. Now, as far as the second part, or the percent error or relative error, by definition is dx over x. In other words, the amount of the error over the actual amount that it's supposed to be. So the amount of error, I'm going to stick with this or that one because it's exact. But what is x? X is 20 times cosecant theta. Theta is 30 degrees. Sine of 30 is 1/2. Cosecant theta is a 2. So the numerator is this. The denominator is 20 times 2. Again, I'm using the fact that x is 20 cosecant theta and 20 times 2. Okay, I've explained everything here. Sine versus cosecant. And so what happens is, twenty times 2, 20 times 2 cancel each other. We get minus times plus minus. It makes it still minus plus, or plus minus makes no difference. Square root of 3 pi over 180. Exactly, if you put it into a calculator, plus minus 0.03, which means plus minus 3%. If they want relative error, you can stop here. If they want percent error, you have to change it to a percentage, as it's the case here.